Let's continue in section 5.1. Example 5 is similar to the examples in the previous video. So if you think you might know how to do it, pause the video and try the problem for yourself. To solve this system, what I would like to do is use the elimination method, and I would like to multiply the second equation by 3. And when I do that, I get 9x minus 3y equals 24. And then the first equation can come down. Negative 9x plus 3y equals negative 24. And then when I add the equations together, everything cancels. And so we have an identity. We know that the lines are coincident. We know the equations are dependent. We know that the system is consistent. And we know there are infinitely many solutions. How do we write the solutions? We need to take one of the equations and solve for x. How do we know to solve for x instead of y? Because the directions say y should be arbitrary. When y is arbitrary, we solve for x in terms of y. The second equation is just a little bit easier to work with than the first. So let's use the second equation. Let's write 3x minus y equals 8. So if we add the y to the other side, we have y plus 8. And then x is y plus 8 over 3. So we're ready to write our answer. Remember, the answers are ordered pairs. And in this case, the value of x we just found is y plus 8 over 3, where y is any real number. So what we've written here is the set of all ordered pairs, x comma y, such that y is any real number and x is y plus 8 over 3. Okay, that's a good problem. It's one that a lot of students find difficult. The most common mistake that I see on the exam is for a student to determine there are infinitely many solutions and then stop there and forget to go on and solve for x and write the final answer. So be careful when you're doing this in the homework and on the exam. Okay, let's go on to example 6. Example 6 is a 3 by 3 system. And so mostly we're using the elimination method like we learned before, but it's just a little bit more complicated with the extra equation and the extra variable. The first thing I'd like to do is just number off the equations so that when I'm referring to them, I can refer to them by their number. And then step 1 is to choose any two equations and eliminate the variable of your choice. Again, elimination is really the way to do this. In theory, you could use substitution, but let's not do that. Choose any two equations and eliminate the variable of your choice. Which two equations would you like to choose? It doesn't really matter. You might be able to save a little work if you choose carefully, but at the end, as long as you're careful and you follow all the steps, you'll get the same answer. I see that in equation 1, the coefficient on x is 1, and in equation 3, the coefficient is negative 1. And so if I just add equation 1 and 3 together right now, then I can eliminate x in one step. So let's do that. So let's choose 1 and 3. And eliminate x. And so I'm going to take the time to copy the equations down before I add them together. It's very easy to make a careless mistake, and so we just want to show all the steps and try to avoid the careless mistake as much as possible. Okay, the x's cancel. We're left with minus 4y plus 2z equals 0. And that's an important equation. We should go ahead and number it. We can call it equation 4. If we wanted to, we could go ahead and cancel a common factor of 2 in this equation, but that's not going to help much. So let's just leave it the way it is for now, and then we'll do something else with it in a few minutes. Okay, step 2. Step 2 says choose a different pair of equations and eliminate the same variable. Okay, so if we chose equation 1 and 3 last time, maybe we should choose equation 1 and 2 this time. And of course, we're going to have to eliminate x again. And so how would we do that? We just need to multiply equation 1 by negative 3. Okay, so again, be careful so we don't make a silly mistake. Multiply the first equation by negative 3. We're going to get negative 3x plus 9y plus 6z is equal to positive 9. And then the second equation, we don't have to do anything except copy it down. And then when we add them together, we get 11y plus 5z is equal to 21. Okay, let's call this equation number 5. So equation number 4 was the result of the first step. Equation number 5 was the result of the second step. Notice those two new equations only have 2 variables instead of 3, and notice they have the same variables as each other. So in equation 4 and 5, we have 2 variables, we have 2 equations. in terms of the two variables y and z. So what do you think we should do with those? Maybe it makes sense in step 3 to solve the 2x2 system. From equation 4 and 5. So let's just write it down for starters. And so how would you like to solve this system? We've been doing a lot of elimination. Maybe we should just do elimination. We could multiply the first equation by 11, and we could multiply the second equation by 4, and that would eliminate the variable y. So we would get from the first equation negative 44y plus 22z equals 0. And the second equation, 44y plus 20z is equal to 84. And when we add those together, we get 42z is equal to 84. So z is equal to 2. Okay, we're not done solving the 2x2 system. We still need to solve for y. So let's go back to this first equation in the 2x2 system. It says negative 4y plus 2z is equal to 0. And let's just replace z with 2. Negative 4y plus 2 times 2 equals 0. And we can solve for y. So we'll have negative 4y plus 4 equals 0. We can subtract 4 from both sides and have negative 4y equals negative 4, or y is equal to 1. All right, things are looking good. We finished the third step. The last step is the shortest. It's to go ahead and solve for the remaining variable. In this case, that's x. That's the variable that we eliminated at the beginning of the problem, so now we need to come back and take care of it. So step 4, solve for the remaining variable. And all we have to do is go back and get one of the original equations and plug in for y and z and solve for x. So we have x minus 3y minus 2z equals negative 3. That should work fine. So equation 1 was x minus 3y minus 2z equals negative 3. And then we can substitute for y. We'll put in a 1. And for z, we'll put in a 2. And let's see what we get. X minus 3 minus 4 equals negative 3. X minus 7 equals negative 3. Add 7 to both sides, and we'll have x is equal to 4. Okay, this time our solution is an ordered triple. This time our solution looks like an ordered triple x, comma y, comma z. where x is 4, y is 1, and z is 2. And you can come back and verify that that's true. You can plug in these values for x, y, and z in each of the 3 original equations and see that they make true statements.